and welcome back. Today I'm going to try to explain why the Soviet rangefinders are so goddamn hard to adjust for shutter speeds, for correct shutter speeds, if not impossible actually. And to explain this, I'm going to make a comparison between two cameras. This is a Zorki I, a black repaint, and this is a Canon 2D. Now the Canon is basically a Leica, so it's pretty much a copy of the Leica I, with the main difference being the rangefinder assembly that is different. It has a single eyepiece, it has the rotating prism, 3 magnifications, it's something else. But everything regarding the shutter is basically a clone. Okay, so both are opened. The Canon right now lacks a couple of pieces, these that I will use to explain what everything does. The Zorki is basically somewhat operational. It's rough, it's tough, it's made in Russia. This one, something else. All right, so in order to be able to explain what's going on, we need first to go back to the roots just a bit, and I'm going to try to explain the principle, so how the shutter is working. So I'm not going to discuss the film advance mechanism, which is basically a couple of gears, but I'm going to start from the actual area of the shutter where the shutter starts or begins, or better said, I'm going to start with the first part that is actually part of the shutter, and that part is this one. So this gear is what connects the advance mechanism to the shutter. It's a tooth gear that has a pin on the upper side, and that pin will be engaged by this pin that is on the underside of the sprocket gear. So basically, when you are turning the advance knob, that pin rotates that pin, and that means that this gear will transmit the rotation to the shutter. When you release, when you push on the shutter button pushes this gear downwards, and the two pins become disconnected, and at that moment the tension inside the shutter is able to pull the curtains. Okay, now this gear that I've been talking about is meshed to this gear. This gear has a cutout, and inside that cutout, that is like a semicircle, but it's not a semicircle, it's more like three quarters of a circle. Inside that cutout there's a screw. The screw is part of the case, so the screw is screwed in the bottom part of the shutter crate, and it is limiting the rotation of this gear. Basically, this gear tells the shutter how much it can travel, so it gives the maximum on this side and the maximum on this side, so you can only move the curtains from here to here. All right, next gear is this one. This is part of the lower roller, and on the lower roller you have the ribbon that is connected to the first curtain. On the upper roller you have the ribbon that is connected also to the first curtain. In the middle there's the drum. The drum holds the second curtain. So rollers first curtain, drum second curtain. On the other side there are two spring loaded shafts, and the spring loaded shaft is basically something like this. So you have a central shaft that is fixed and a drum or a roller on top. And if you open this up, you will see a shaft, a spring, and a upper cap or a top cap. The spring is fixed to the shaft is fixed and unable to move inside the camera. The upper roller or the top cap is part of this. The upper part of the spring is connected via this little spring hook to the cap. So basically the spring is also connected to the center and also connected to the outer part. And that means that when this is under tension, it will always want to go back. And what that actually means is that when you are tensing or putting tension on the shutter by turning the center part, so this slotted part, which is actually the shaft, you are putting tension on the spring, because you are twisting the spring like this. So you are twisting it counterclockwise. The outer part remains stationary because it's connected to either the ribbons or the curtain, and those are being kept stationary by the limiting gear. Okay, I hope it makes sense. When you wind the shutter, these rollers begin to spin because obviously they are connected to this part, and add even more tension. When you release the shutter, they will try to move back, so the spring will try to release the tension. All right. Now, what is the connection between these two? Let's find some more shutter parts. So, this is the drum. This is the main shaft. This is the lower gear, roller, and this is the upper roller. Okay, and then we have something for everybody. We have this, and we have this, and we have this, and this. Okay. This part I don't need. Oh look, one of these little guys. And I think I have a special little box for, but I don't know where it is, so I'll just leave it here before I lose it. This part I don't need. This is the lower roller, as I previously said, and this is the tooth gear that is connected to the rest of the gears. And this is the upper roller that goes here. Okay, so when this is turning, the main shaft, the rollers are acting on the ribbons. The ribbons are connected to the first curtain. So all this is doing is pulling the first curtain. There must be a way to connect the two, because when you are winding the camera, both curtains travel together. There is one big cutout in the upper roller, okay? And there is one little cutout in the drum. Other models used different cutouts. Some have two, some have a longer cutout, like this Canon. So the design varies. I don't know if I have maybe a Fed. Let's see. Yeah, see, this is the drum of a Fed 2. See, instead of a round hole, it has a more elongated cutout. Although I am wrong, because in the case of this one, this is the cutout that's important. So it's the equivalent of a round hole. This one has an elongated cutout and a round cutout. I am not really sure why, but I'm sure there's some explanation to it. Okay, so this one goes like this, and if you let me get this on the bottom, see, that round cutout can move from here to here. It can't move any more than that. This little guy is underneath this disc with the holes. That is the shutter speed selector disc. And this little guy is actually this. Actually, it's the brass part that you can see in the middle, because this is a two-part bigger part. This one is hanging below this plate, and this part is something like this on the top. Okay, and this one can spin. Now this little guy goes like that, so the pin must engage inside that round hole, and that means that right now this can only move from side to side. When the shutter is released, this one stays like this, and when you turn the center shaft by the means of all those gears, it will rotate like this, and it will force both the rollers and the drum to spin at the same time. When you release the shutter, the second curtain must be delayed. So the first curtain opens, and after a certain amount of time, the second curtain closes. Otherwise, both curtains would start moving at the same time, and you'd have blank exposures. So if by some means you can keep the center still, so the drum will stay stationary, the rollers can move clockwise freely. That means the first curtain opens, and then at some point when you release the drum, it will also be able to rotate clockwise freely, and that means the second curtain closes. All right, so this is how they both move together and independently depending on what is going on with the camera. Now on top of this part, so the engagement pin, there is also this thing that goes like this on top. Okay, so this aluminium part is clamped on top of that brass part, and from this point onwards I can use the Canon to describe the mechanism further. This is the aluminium part, that's the brass part. This is the second curtain latch. I'm going to put these back before I lose them. And I'm going to get one of those latches out. So it looks like this, a cone, or no, not cone, a cane-shaped latch. So it looks like the cane of an old man. And this latch is being pushed down by this spring. So every time you push on the shutter button, the latch moves down. Every time you release the shutter button, the latch moves up because it's pushed up by this flat spring. Obviously the flat spring has a lot more force to it than this little spring on top. But when you push the button down, the latch goes down, and if the shutter is cocked, this prong, see this prong here, is inside this cutout. So when you push the button down, the latch moves down and stops, catches and stops that piece. Now that piece is connected to that underpin that is connected to the hole in the drum, and that means the drum will remain stationary. When you remove the finger from the shutter button, the second curtain slams shut. Okay, so this is the way the camera holds the second curtain in place until the shutter speed that you've selected needs the second curtain to close. Okay, in order for it to close at different times, because in this case this is B, you push the button, it opens, you take your finger, it closes. But the camera, for a certain selected shutter speed, must do this on its own. So in order to do that, you have a shutter speed control disc. So it's a disc with different holes in it that goes on top, like that, and spins with the shaft, with the central shaft. So this disc spins with the first curtain, and it's affixed to the shaft via a screw. Okay, and on top of that you have this little guy, which is the release prong for the second curtain. It has this tip and it has a little pin. That little pin engages in one of these holes. And let's say, now for a cocked shutter, this should be something like this. Yep, and right now the hole in this brass part is aligned with the hole in the shaft. Okay, and let's say I am selecting 1/60th of a second, which is this hole. By now I know them by heart. So 500, 250, 100, 60, 40, 30, and B. In the case of this camera, of the Canon, I should be checking the shutter speed knob, and I could tell you for sure what the sequence is, but it's B 25th, 40, 60, or 50, 80, something like that. But the last three, the ones that are closer together, are almost always 100, 200, and 500, or 125, 250, 500. Or if there's one more, that would be 1000. All right. Anyway, for 1/60th of a second, this thing should be here. Now, what this does is when you trip the shutter, the first curtain starts moving. The first curtain is connected to the central shaft. This piece is connected to the central shaft, and it starts rotating. When the tip of this piece reaches this point, it will push on the second latch. When the second latch is pushed aside, that little thing escapes and starts rotating with the second curtain. That's the basic operation. That's how you adjust the speed. If you move this to another hole closer to the latch, the time between the moment when the first curtain starts moving and when the second curtain starts moving is shortened. If you move it another notch, it's shortened even more. If you move it another notch, it's shortened even more. If you move the other way around, like this, the time is lengthened. If you move it all the way the other way around, the first hole, which is B, this thing happens. It stops short, so it never pushes on the latch, and the latch remains pushed down because I've got my finger on the shutter button. So it will release not because it's pushed away, but because it's pushed up. Basically, the latch releases either being pushed away, either by being pushed up. Right. If I move it to the next hole, it will make a not a full circle. It will make the entire travel from here all the way to here, will hit on the latch, push it aside, and that means 25th. All right. Now, this is the theory. What's the difference in the case of the Soviet cameras? Well, in the case of the Soviet cameras, we are going back to the little bag of parts. This thing, which is this thing, looks pretty similar, but if I turn them around, notice how longer this pin is compared to this one. What that happens, or let me rephrase, why is this discrepancy? Well, because look at how the latch is designed in the Soviet cameras. See, this part is flat. This part has a raised thing. In the Leica I, for instance, this thing is actually an eccentric that has a slot, so you can rotate it, and by rotating it you are moving the tip of the circle more towards the left of the camera or more towards the right of the camera, and thus you are changing ever so slightly the moment when it is pushed aside by the tip of this part. And basically that's how you adjust for 500th and 1000th of a second, and that's actually part of the adjustment sequence or procedure. In the case of this, it's a bit more basic because it has no cutout, so I can't turn it. I don't think it's an eccentric, I think it's just part of the actual latch. In the case of the Soviet cameras, no adjustment possible. So what you get is what you get. All right, so because it doesn't have that raised part, the only way this thing can push on this thing is by having a pin, and that pin will actually trip and push on the latch. But because this pin is longer, you can't really see it, but you'll need to trust me. Let me try. Okay. See, because of the length of the pin actually goes more towards the bottom of the camera than this part that is connected to the second curtain. So basically, even if I keep my finger on the second curtain, let me select 500th of a second. So I will keep my finger on the second curtain and I will release the shutter. See, the shutter won't open because or better said, the first curtain will not move without the second curtain because that pin has already hit that part and cannot rotate anymore unless it pushes on that, and by doing that it pushes the second curtain. I hope it makes sense. It's a lot easier to see, to actually have it in front of you and see, but this is the hard lock between the two curtains. The two curtains should be normally independent, so each should be able to travel with its own speed and its own parameters. But in the case of the Soviet cameras, they are interlocked physically. The only speeds that do not have this interlock are the flash sync speeds, meaning in this case 25th and B. And it's very easy to see which speeds are interlocked and which are not. So right now the camera was set to 500. If I only turn the second curtain, the first curtain comes along. It's being pulled by the second curtain. Because the second curtain, which is this prong, is pushing on the first curtain, which is the pin. Okay. If I select the next hole, which is 250, the same thing happens, but the gap is larger. If I move to 100, the same thing happens, but the gap is even larger. If I move to 50, the same thing happens, but the gap is larger. If I move to 25th, the second curtain went all the way to the other side of the film gate without engaging the first curtain. If I could turn more, then it would engage. So that means that for this speed, the first curtain will travel all the way to the other side before the second curtain is released. So that's the only speed at which the two curtains are truly independent. All right. Why is this important? Well, because this means that the shutter can operate somehow or in a certain manner, even if the second curtain has no tension at all. So I can remove all tension from the second curtain and it will still do 500th of a second. I could demonstrate, but I'm too lazy. You will have to trust me. It's logical. The first curtain just pushes the second curtain along, so it will do that time. But the actual major implication is the fact that if let me rephrase. The curtains start moving from here and go all the way to here. Okay, it's not a big distance, but there is a distance, 36 millimeters. It starts from zero speed, zero whatever centimeters per millisecond or whatever. Okay, so from zero speed, and it goes to maximum speed, and then maybe it decreases or not. That I don't know. I don't even know how you can measure it. But because it starts from zero and goes all the way to something, it means it accelerates. So you don't have a constant travel, you don't have a constant velocity shutter, you have a constant, if you're lucky, acceleration. So it will accelerate more and more and more until it stops. That unless the spring fatigue is great enough that the shutter will start accelerating, and from some point it will start to decrease its acceleration. So it will be something like this, a graph of the acceleration. Because it is accelerating, it means the speed is increasing, and therefore the time that the film receives light for any given gap is shorter and shorter and shorter. So you would have a gradient of exposure, more exposure here, less exposure here. In order to compensate for this, you would need to increase the gap as you move towards the left of the frame, because the curtains are moving faster, and therefore the time is shorter and shorter and shorter. So you need more and more and more exposure area. In order to do that, you need to have two different diameters for the roller, the drum, and the two rollers. And that is because they both turn with the same angular speed, right? Because the pin is pushing on that little prong. So basically everything that's on this shaft is spinning with the same speed. Therefore, only by varying the diameters you can make one curtain move faster than the other. And you need to make the first curtain move faster, and therefore you need bigger diameter rollers that would allow for more ribbon to be released for the same amount of spin. That is the big difference between these two cameras. In this case, there is no connection between the two curtains, and you can adjust them independently, and therefore you can adjust by lowering the tension on the second curtain, so the second curtain will always travel slower, and that difference in speed will allow for the increase in gap. In this case, you can't, because even if you release all tension, it will still move with the speed that's dictated by the first curtain. And what I found, unfortunately, is the fact that pretty much always there is a gradient, an exposure gradient in these Soviet cameras, at least in the Zorki I. In the Zorki I, because that's pretty much the only Zorki I've been fixing for the last couple of months, ever since I've finished my shutter tester. And even in a brand new, even in an unopened camera, there's a very big exposure gradient. It's something like, let me check. Okay, so this is initial shutter speeds, average of 10 measurements for various speeds in a Zorki I, so before CLA. This is 100th of a second. Left side, right side, center. 105 in the middle, that's okay. 150 on the left, 172 on the right. For 200, pretty much bang on, 200 in the middle. 110 on the right, 282 on the left. That's not good, right? Because from here to here you have more than twice the exposure. 500, 409 in the middle, that's good enough. 156 on the right and 655 on the left. I mean, this is the difference from 1/25 to 500. So 2 stops difference, 2 stops gradient. And unfortunately, the only way I found to be actually working to compensate for that is to actually add another layer of ribbon material underneath the actual ribbon of the first curtain. So by doing that, you are increasing the diameter of the rollers. But when you are doing that, something else happens. The rate of overlap is increased. So you need to actually move the insertion points in such a way that the curtains still start where they're supposed to start and still finish where they are supposed to finish. And that is totally empirical. I have no math behind it. I have no idea how I could calculate things. I don't know how I can calculate the acceleration because that's the missing key in this puzzle. So right now I'm eyeballing it. So basically I just add a full turn of ribbon underneath the existing ribbon. It seems to be working, not quite enough. Maybe I've tried also adding shutter material, curtain material, but that seems to be a little bit too thick. So one full turn will increase the diameter quite a lot. And you can calculate this pretty easily. What happens if you increase the diameter by 0.2 millimeters? Because actually 0.26, because the ribbon is pretty close to 0.13 millimeters thick. So if you add one full turn, you will increase the diameter by 2 or 2 by or 2 multiplied by the thickness of the ribbon. And for that new diameter you can calculate the circumference, and you will see the difference between the initial circumference and the altered circumference. Okay, I think that's pretty much all I wanted to say. It's a very tricky thing. I'm not really sure, but I have a hunch that at some point, somewhere around the Zorki 4 period, they changed or they increased the diameters of the rollers, because the Zorki 4 is a bit better. But on the Zorki 1, all Zorki 1s that I've measured, they are all not great. Okay, that's about it for today. Thank you. I hope this was helpful. I hope I managed to explain it as good as possible. I'll see you next time. Bye.